Hello, you're welcome to my study room. This is Mr. Chu, and today we'll be doing maximum and minimum value and point of a quadratic function. A quadratic function is of the form f of x equals ax squared plus bx plus c, where x is a real number, a, b, and c are constant. And a is not equal to 0. It is an equation of the second degree, meaning that it's an equation in which the highest exponent or power of x is 2. All right. The graph of a quadratic function opens either upwards or downwards, depending on the coefficient of x squared. That is our a. If a is greater than 0, the graph opens upwards, and if a is less than 0 or is negative, the graph opens downwards. And for the graph that opens upwards, we'll have this point, the turning point of the graph being the minimum value. And then in the case where the graph opens downwards, the turning point becomes the maximum value. All right. Then we can go ahead and graph a quadratic function. So let me just quickly sketch my Cartesian plane, having our x-axis, then the y-axis here. So that when we sketch this one, the graph with the minimum value, we sketch something like this in it. We'll trace here to the y-axis. Because it's a negative number, maybe let's call it b, negative b. And then that becomes our minimum value. So our minimum value will be y equal to negative b, or simply negative b. And then if we want to get a point or our minimum point, you know a point involves both x and y coordinate. So let's call here, because here 2 is negative, maybe let's call it negative a. Then our minimum point becomes the x coordinate first. So we have negative a comma negative b, and that becomes the minimum point of the graph, and the negative b is the minimum value of the graph. Then also in the case where we want to sketch the second one, where a is less than 0 or negative, our graph will open downwards. Our graph will open downwards this way. Let's call it this way. Then this is the turning point of the graph. So when we trace this to the y-axis, this is positive y. So maybe let me call it B. And then we trace here to the x-axis. This is also positive, so let me call it A. I just decided to call this A because we write the x component first before the y component. That's why I decided to write the XA and the YB. All right. So the maximum, remember, this is open downward. So the maximum, we cannot get a minimum value here. The maximum value will be positive B, the highest point of the graph, and the maximum point will combine the x value at which it occurs, which is A, and then the y component B. So if we are to sketch or we are to plot the point of this function, of a quadratic function, these are supposed to be the minimum and maximum values and points respectively. But the aim or the purpose for today's lesson is when we are just asked to find these values without necessarily sketching the graph. We are just to find these values without necessarily sketching the graph. What do we do? That is the aim of today's lesson. All right. So if we are giving generally, if our question requires us just to find the maximum or minimum value without sketching the graph, then we'll transform our original function, which is f of x equals a x squared plus b x plus c, into the form f of x equals a parenthesis x plus d all squared plus k, where k is the maximum or minimum value depending on the nature of the curve. And this value occurs at it occurs here when this is equal to 0, x plus d equals 0, which means that x equals negative d will be the x component where we will have k. So that is what we are going to do now. We take the very first example, which requires us to find the minimum value of Good. So we have to find the minimum value of f of x equals 3x squared minus x minus 6. And we have to find the value of x at which it occurs. So the first thing we'll be doing will be for us to factorize the coefficient of x squared, which is 3 out, so that the coefficient of x squared becomes 1. In fact, here we are just using the method of completing of squares, completing the squares method. That's what we are using here. So we have our 3x squared, sorry. So when we factor, uh, when we factor 3 out, our function is now going to be 3 out. Here divided by 3 will give us x squared. Here divided by 3 will give us 1 over 3x. Here divided by 3 will give us 2. Then we have factored 3 out. The next thing we are going to do is to take half the coefficient of x. We take half of the coefficient of x. So the coefficient of x is 1, negative 1 over 3, of course. And we take half of it is by simply multiplying it by 1 over 2. And that will give us negative 1 over 6. So now we are going to add and subtract the square of this to our function here. So the function now becomes 3. Now we introduce a bracket, x squared minus 1 over 3x, then plus our new negative 1 over 6 squared, then minus the same thing, negative 1 over 6 squared, then now minus our 2 here, minus 2. We close our bracket. Then now we are going to factorize this side from here to here. We are going to factorize. And by factorizing, the easiest way I can explain that right now is you pick one of the squares. You pick one of these, you pick one of these, and you square both of them. When you factorize, that is what you are going to get. So that will give us, let's introduce another parenthesis inside the bracket. X for the first square, then minus 1 over 6 for the second square. Then you square both of them. That means you have factorized this. Then now we have minus negative 1 over 6 squared is 1 over 36 minus 2. We close our bracket. Let's continue. So now after doing this, we need to simplify this side of the expression. So that is going to give us our 3 outside, we open bracket, the first one in parentheses, x minus 1 over 6 all squared, then minus subtraction. So here our LCM is going to be 36. 36 will go into 36 1 times 1 is 1, then minus, this is 2 over 1, so 1 into 36 is 36 times 2, 72. All right, so when we simplify further, we are going to have then simplifying this, negative 1 minus 72 give us negative 73 over 36. Then we now use these 3 to open the bracket. So using the 3 to open the bracket, not the parentheses, we are going to have 3 parentheses x minus 1 over 6 squared. Then this one multiplying this fraction, it will divide the 3 here. So it will divide the 36. So 3 will go into 36 12 times. So minus 73 over 12. At this level, we have now expressed the question, which is f of x equals 3x squared minus x minus 6 in this form. Let's use another color. In this form. We'll now express it in this form now. So here it means that our a is 3, our d is negative 1 over 6, and then our k is negative 73 over 12. So our conclusion is now going to be hence the the minimum value is our k is negative 73 over 12. So negative 73 over 12. And it occurs at x minus 1 over 6 equal to 0, which implies that x equals 1 over 6. So our minimum value is negative 73 over 12, and it occurs at x equals 1 over 6. Let's take another example quickly. Example 2. Find the maximum value of right. We have to find the maximum value of the function f of x equals 1 plus x minus 2x squared, and the value of x at which it occurs. So again, whether maximum or minimum value, our a will determine. In this case, our a is negative 2, which is less than 0. So here we can only find the maximum value and not the minimum value. So here we start right away by rewriting our function as negative 2x squared plus x plus 1. We factor our a out, which will be negative 2 out. We have x squared minus 1 over 2x minus 1 over 2. Remember that the signs inside have changed because of the negative 2 outside here. So that when we use this negative 2 to open this bracket, we will get our question back. That's why the signs inside have changed. So the second step is we are going to take half of the coefficient of x, which is negative 1 over 2, and that will give us negative 1 over 4. We add and subtract the square of that to the expression here so that it becomes negative 2. We introduce a bracket plus, remember this is negative, so we pick it, so negative 1 over 4 all squared, then minus negative 1 over 4 all squared minus 1 over 2 now. We close the brackets, very important. Then we factorize this side, and that's going to give us negative 2 bracket open. We introduce parentheses x minus 1 over 4. We pick this, we put them together, we square both of them. That's why we factorize this out. Then minus 1 over 16 minus 1 over 4. We close our brackets. Then we simplify this side. So you get negative 2 bracket open parentheses x minus 1 over 4 all squared minus, when we simplify this, the LCM is 16. We're going to get 1 minus 4. Sorry, there was a mistake in me transferring this 1 over 2. So let me quickly correct that. So is this 1 over 2 that we are putting here? It's not 1 over 4, it's 1 over 2. All right. So 1 over 2, we are just transferring this one. We didn't do anything. It's this one that we simplify. We just square. So 2 go into 16 8 times. We close. So now we simplify further to have negative 2 bracket x minus 1 over 4 all squared minus 9 over 16. Then the next thing we'll be doing will be for us to open the bracket with the negative 2. So when we open the bracket, that is going to give us negative 2 x minus 1 over 4 all squared, then plus 9 over 8. Remember, that is 9 over 8 because this negative 2 multiplying a negative number, it will now be positive. And also these two will divide the 16 to give us 8. So the maximum value of f of x occurs here. So at x minus 1 over 4, which implies x, which implies x equals positive 1 over 4. All right. So we conclude, hence, the maximum value of f of x is 9 over 8. These are k. 9 over 8. And it occurs at x equals 1 over 4. All right. So this is how we find the maximum or minimum value of a function if we don't want to sketch or plot the function on a graph book before finding. So I'll give you one to try on your own, which is question 3. Express y equals 5 minus 2x minus 4x squared in the form y equals a minus b bracket open x plus c all squared, where a, b, and c are constant. Hence, state the maximum value of the function. So here, hence state the maximum value. Let me just write that. Of the function of x maps onto 5 minus 2x minus 4x squared. And here, when you finish, the answer you are supposed to get is y equals 21 over 4 minus 4 into bracket x, or parenthesis x plus 1 over 4 all squared. This is supposed to be your answer for this. Then the maximum value of y is equal to 21 over 4. Remember, here it's just, instead of writing negative b into bracket x plus c all squared plus a, they decided to bring the a first. It doesn't change anything. So it's just a matter of you bringing your k first instead of the k to the last. So don't be confused by that. Let's take assignment. All right. Express the following quadratic functions. All right. So express the following quadratic functions in the form a into bracket b plus x all squared plus c, and then state the list of greatest value of y and the respective value of x at which it occurs. So these are the questions. Question A, y equals. All right, so try your hands on these questions, and I wish you all the best. I hope what I did today will guide you or help you to be able to explain all of this well or solve. Sorry, this is y equal to negative. All right, I had a very little network challenge over there, but that is the end of today's lesson, and I want to use this opportunity to thank you so much for making time with me today. Expect more videos on different mathematics topics. Please subscribe if you haven't done that yet. Thank you so much. Bye bye.